Okay, so I think I'm recording. This is a test, but we'll see. We're going to do some engineering design notes. So what you need to do is get your notes packet. So if you came into the school building and got a notes packet, please just get that out. And we're going to take notes on the first 3 pages inside that packet. If you did not get a packet from me, you can still come and get one. You can use your own paper to take some engineering design notes right now, then transfer them into the packet later. You can pause the video, you can go and in our classroom resources, I have put the notes packet in a PDF format and you could print it, or I don't know what else you want to do with that. But anyway, contact me if you have any questions about that. I did make a physical packet for each one of you. If you want to come and pick it up at the high school, I think you will enjoy that format much better than printing or writing it on a separate sheet of paper. But engineering design notes. So we're talking about engineering because it's so closely tied to science. And so the very first question in your notes packet on the inside of the cover is, what is engineering? And so we're just going to take some notes together, okay? Well, gotta get a marker that works. Okay, what is engineering? Engineering is designing to solve a problem. Designing to solve a problem, okay? And it comes from Latin. The word would be ingeniare. Not sure if I'm saying that right. I don't speak Latin. Ingeniare, which means to design or to devise. To design or devise. Okay. All right, then it says in 2008, the National Academy of Engineers published 14 grand challenges for engineering. They are listed below. Make notes next to these goals as needed to aid in your understanding. So the first one says make solar energy economical. So hopefully you guys know that economical means more affordable. So we're trying to make solar energy much more affordable. The next one, provide energy from fusion. Whether or not you've been in a space science class, you may have heard the word fusion. Fusion is what happens in stars, and that's what puts out all the energy that makes us possible here, okay? So the process that happens in stars, I'm trying to use that, harness that process here on planet Earth to make energy. Develop carbon sequestration methods, okay? Sequestration means capturing. So carbon sequestration isn't really capturing carbon, it's capturing carbon dioxide. So carbon dioxide levels in the atmosphere are on the rise. Carbon sequestration methods would pull carbon dioxide out of the air, which is something that plants do all on their own. So, you know, plants are a good method for that, but if we can create an alternative method as well, we can help that reduce the CO2. The next one, manage the nitrogen cycle. Next one, provide access to clean water. Might be an interesting fact for you to know that 1 billion people do not have clean water on this planet. 1 billion people do not have clean water. Restore and improve urban infrastructure. Okay, hopefully infrastructure is a familiar word to you, but that's roads, bridges, sewers, just the structure, the base of our cities, towns, and transportation lines. Advance healthcare health informatics, okay? Health informatics. Informatics is like information and how we store it. So health informatics is how we store health history. There have been technological advances where you can put a microchip in a person's wrist or somewhere maybe in a neck where that has their health history. And if we can get to a point where we have that, then anytime, anywhere in the world that you are, if you had an accident, your health history would be with you. They wouldn't be wondering whether you were diabetic or whether you were allergic to things. Reverse or engineer better medicines is the next one. That one's pretty self-explanatory. Reverse engineer the brain. So if engineering is devising and designing, we're not trying to design a brain, but we're trying to figure out how does the brain work. So reverse engineering is figuring out how something that already exists works. Prevent nuclear terror, secure cyberspace, enhance virtual reality, advance personalized learning, that's kind of what we're doing right now. Engineer the tools of scientific discovery. Okay. All right, so 2, why are we learning about engineering in a science class? That's the next question, okay? And I kind of already answered that. Science and engineering can't be separated. Science and engineering can't be separated. They depend on each other. So we can't design and devise solutions to problems if we don't understand the science behind what we're using to create these solutions. But we also can't do advanced science without the tools that have been engineered for the use in science. So we're going to combine these subjects a lot because they are so intertwined. Okay, 3, what is the engineering process? All right, what is the engineering process? That first bullet right there, it is a systematic problem-solving strategy. Systematic problem-solving strategy. And it's got 4 sub-bullets there. It works with criteria and constraints. Works with criteria and constraints. And just to define those terms a little bit further, criteria would be requirements, and constraints would be limitations. All right, next sub-bullet here, okay, our systematic problem-solving strategy. It's used to develop many possible solutions. Used to develop many possible solutions. Then narrow down to a final choice to solve the problem. So used to develop many possible solutions, then narrow down to a final choice to solve the problem. Narrow down to a final choice to solve the problem. So there's not really one right answer. When you're trying to solve a problem, there's all kinds of different ways that you can do it, especially complicated problems. And so this is a way to develop possible solutions, work with those possibilities, come up with your favorite or the best or most economical or whatever it is, most efficient, and then go with that one. Okay? Engineering is a social and collaborative process. Social and collaborative process. Engineers work together, they have teams, and the more brains you have on a team, the more ideas you're going to come up with, and the more likely you're going to come up with a solution that works and is efficient and cheap and all of that. Okay, so more ideas is always better. Okay, we don't want to ever discount an idea when we're engineers. Okay? All right, and then it is an iterative process. Now that might be a new word for you. ITERATIVE. Iterative process. Okay, it's repeated for improvement. It's modified and it's tested. Okay, repeated for improvement. Repeated for improvement, tested and modified. Tested and modified. Okay. So when you test things, you modify them, then you repeat and you test them and modify them, and that's kind of what we do when we're trying to engineer something. We're going to go through this process several times until we can really hone in on the perfect solution. Okay, on the next page, you're going to see kind of a flow chart, and we're going to go through that flow chart. So the design process. The first part of the design process says define the problem. I'm just going to define just to, it's already there for you, so you don't need to write that, okay? But really, we're just identify what's needed. Identify what's needed, okay? Create design requirements. Create design requirements. That's going to be your criteria and constraints, okay? Criteria and constraints. Now, in a true engineering project, one of those constraints is always going to be cost, okay? So how much money do we have? And that's gonna really limit what you're able to do as potential solutions. Okay, after we define the problem, we're gonna go to our second part of the process. We're gonna generate concepts. Generate concepts, okay? This is gonna be brainstorm and research. Okay, try to find things that already exist that might be a good starting point. Apply STEM principles or STEAM principles. Okay, science, technology, engineering, art, mathematics, apply STEAM principles. And then select an approach using a design matrix, which we're going to go over on another page here. Select an approach using a design matrix. All right, number 3, develop a solution. Okay, develop a solution. You're going to create a design. Create a design. Make technical drawings. Make technical drawings, okay? So that is going to mean it's going to have instructional information on materials, size, shape, assembly. It's not just a drawing of what you want to make. You have to have all kinds of details in there. So usually there's a visual, but also a lot of writing in a technical drawing to show what's there. All right, the next is construct and test a prototype. Construct and test a prototype. So you're going to build a testable prototype. Only of the solution that you selected. So you're going to build a testable prototype. Okay. Then you're going to test it and collect data. Test and collect data. Okay. How did it work? Okay. So that next piece, probably pretty obvious what you would do after you test it, is evaluate the results. Evaluate the solution. Was it effective? Okay, was it effective? Can it be improved? So improvable? Not really sure if that's actually a word, but then you're going to optimize and redesign if necessary. Optimize and redesign. Okay. Then we have a couple of options. If we have found something that we're happy with, it's successful, we're going to present the solution. Okay, and that would be like a lab report here. A lab report. But if we were in a company, we'd be presenting that solution to whoever would be manufacturing or whoever has asked us to solve a problem for them. Okay? If this is not a successful prototype, then we're going to go back up and either come up with more concepts, choose a different idea from before, or maybe even just reevaluate the entire thing. So this is a process that we will use. We'll return to those previous steps and repeat them as needed. Okay? I'm going to make a separate video for our design matrix page, and you can watch that one there to get the notes for that.